Hello, am I audible for listening? Am I audible for listening?
Yes, sir.
Okay. In the last class, we saw some numerical. Now, today I will give you a basic idea on, how to, what is a free body diagram and how to solve it. So, we will get into this presentation. So, all of us know, I will just give you a basic explanation about this course and, okay. So, what is a force? Force is basically a push or pull. Okay? Force is basically a force that pulls or pull. And it causes the object to start or start moving. We all know this. Right. Now, suppose what happens in force, what happens in force, suppose this is an angle. In this angle, if now this G is coming on downwards. Okay? And the force is given. And then we have Newton's first law. As per Newton's first law states that as per Newton's first law states that an object which is in motion, it always tends to stay in motion. An object in rest, it always tends to stay at rest. Okay? Now, inertia. Inertia is the property of matter that resists the change in motion. Like, Newton's second law states that force is equal to mass into acceleration. And the object will only accelerate if there is an unbalanced motion. Okay? And then Newton's third law, every action has an equal and opposite reaction. These are basically what Newton's law states. Okay. Now we go to the next one. If we go to the next one, see that even if it's hard, we'll discuss it later on. You all know also. Now we'll have some important. Now this is the what? This is called as free body diagram. What is actually a free body diagram? Can anyone tell me any idea regarding what is a free body diagram? Can anyone tell me what is a free body diagram? Can anyone tell me what is a free body diagram? Anyone tell me what is a free body diagram? So a free body diagram is a sketch in which all the four sectors acting on an object are drawn with their initial points at the location of the object. That means what? Suppose this is the this body, this is a body. Okay? In this body, what happens is that one give the answer. So this is the body. In this body, what happens is that if you have to show that how the forces are actually acting, yeah, how the forces are actually acting within this body is the free body diagram. Okay, if you have to show that how the forces are acting on the body, then this is called as a what? Free body diagram. Suppose this is look at this. This is a body. Yeah. So in this body, what happens is that downwards. Yeah, the gravitational force is acting downwards. Yeah. And the normal force. Always remember the normal force is perpendicular and it is acting directly upwards. Okay. Then we have what? We have the applied force. That means what? The force which is applied in the direction of application. Next we have frictional force. So how does frictional force act? The frictional force acts in the direction of opposite direction of friction. Okay. So basically our main aim will be what? To study friction. We will be going to friction. So for free body diagrams is very important while solving the problems in mechanics. Okay. Now for different programming problems and you need to study the free body diagram. It's a very important aspect. Now if we go to the next one, then that is what? Friction. So what is friction actually? If you see in the following figure, suppose a car is moving from 1.1. Okay. As soon as the brakes are applied in the car comes to rest. It means that motion is applied. Motion is opposed. So on what principle does this works? We don't know the principle of friction. Okay? There is a friction between the wheel surface and the road. That means the frictional force acts in the opposite direction. And then what happens is that eventually this vehicle stops. Clear for all of you? Is it clear for all of you?
Yes, sir.
Is it clear for all of you?
Yes, sir.
Okay. Now, now what happens is that this is the friction thing. Okay? Now, what are the different types of friction? The types of friction is first of all sliding, then comes rolling, and then comes fluid. Now, the sliding friction, what happens is that when a solid object slide over one, then it is sliding friction. Then rolling friction comes while rolling, while spinning of an axle, like for a car, vehicle. Okay. And fluid is that friction that arises in liquid object. Now, this is a different type. Now, we'll discuss it in more elaborate. Okay. Now, coming to the free body diagram, just now we discussed the free body diagrams are what? These are the diagrams that are used to show the relative magnitude and direction of all the forces that are acting involved. Okay. Now, suppose this is the object. Okay. Okay. Now, this is applied force direction and this is the frictional direction. So, A gravitational force is directly acting from the center. Okay? The gravitational force is what? Directly acting from the center point, it is downwards. And on opposite direction to the gravitational force, the normal force acts. Okay? Now, principles of friction. And first of all, let us discuss about this chapter. Okay? Principles of friction. What is, what is it and how does it work? Okay? So we have what? Friction means what? That is, suppose the opposing force that is applied to the body. Suppose the body is in motion. Now what will happen is that some opposing force might be applied to it. Right? If that opposing force is applied to that body and there is certain, you know, opposing the motion of the body, there is friction. Now we have, just now we discussed, we have what? Static friction, dynamic friction. Okay? So now limiting friction. So as discussed, static friction means what? The friction experienced by body where it is at rest. Suppose the body is at rest. That means it is not moving, right? It is not moving because it is being accompanied by certain amount of friction. That friction is known as what? Static friction. Okay? Now next is what? Dynamic friction. What is dynamic friction? Suppose an object is in motion. Then what happens? If the friction and force act on it, then it is called dynamic friction. Okay? Now dynamic friction is also called kinetic friction and it has following two types. Number one sliding, number two rolling. Now we go to the next one, which is called limiting friction. What does limiting friction means? The frictional force that is applied in a body and that comes into action when a body just starts to move, or maybe when a body just begins to slide over on the body. Then it is known as what? Limiting friction. Suppose I'm giving you an example. Suppose this is a plane and this is a block of wood. Okay? And this block of wood, what happens is that now suppose what happens? We are applying certain amount of force here. If you are applying certain amount of force here, but it is not moving, that means what? It is static friction. Okay, it is called static friction. Now, what happens is that certain amount of force is applied, and the body just starts to, it just the body just starts to move certain amount of that friction is known as what? Here, limiting friction. Which means a body begins to slide over the surface of another body. Then it is called what? Limiting friction. Is it clear? Is it clear? Is it clear to all of you? What is limiting friction?
Yes. Yes, sir.
So,
Okay. So this is the limiting friction. Now we go to the next part, normal friction. Now look, in a friction body, in this inclined body, suppose I am giving you a straight body here. In a straight body, what happens? There are two components. First of all, this one is the what? Weight, or W equal to what? M mass into what? G. Yes. So this is always acting due to the gravitational acceleration. So it will be what? Perpendicularly downwards. Is it clear how it will act? W. W equal to M into G. Is it clear?
Yes, sir.
Now, look, as per Newton's third law of motion, what happens? Every action has an equal and opposite reaction. So since this force is acting downwards, we will be having another one upwards. This is the equal and opposite reaction part of this body. For this body, yes or no? Yes or no? Yes or no? We have this opposite component. That particular opposite component is known as what? N, or N, or what? Normal. Is it clear? Is it clear for all of you? This
Yes, sir.
particular component is known as the N, or normal force. Now, in case of an inclined body, what will happen? How does the force will do? The G will always act downwards. That is, if, like even if the body is inclined, then G will always act in this manner. Never forget this. But the normal reaction will be normal to the plane surface. That means here it is G or W weight, and the normal reaction will be what? Perpendicular to this one. Perpendicular to this one. Is it clear? Is it clear? G will be perpendicular to this,
Yes,
and
sir.
the normal reaction will be perpendicular to. Okay. So this is how we compute what normal reaction for the G. So I hope the definitions are clear for all of you. If you can see in the diagram here, here. This is what? This is the plane surface. So the normal reaction is acting what? Perpendicular. But the W is acting this one. Okay? Is it clear? And remember one thing. When an object is moving downwards, suppose, here, then the friction will always act in the opposite direction. Okay? So this is how we have to solve it. Is it okay? Now we are going to what? Angle of friction. What is angle of friction? Suppose this is the body of weight W, which is resting on an inclined plane. Okay. Now the body is equilibrium under this criteria. Weight W is acting downwards, normal reaction upwards, and friction is what? At the opposite direction, upwards. Okay. Normal reaction is perpendicular to the plane. Now the inclination, this is an inclination. This plane what happens is that this plane is inclined at an angle alpha. Yes. This plane is inclined at an angle alpha. Okay. Then what happens? If you just push this plane upwards, there will be a certain point of time at which this body will slide. This body will start to slide. So that inclination on which the body just starts sliding, that inclination is the what? Angle of friction. Okay? Okay? Or alpha. It is generally denoted by alpha. And it is also equal to the angle which the normal reaction makes with the particle. That means what? This is the reaction. Now, if you just do one, if you just from this point, if you just put it downwards, then what will happen? Here, an angle will be made. Yeah, the angle that is being made, this particular angle, that is equal to this alpha only. That means this alpha and this angle is what? Same. Take it? Is it clear? Is it clear?
Yes, sir.
Whatever others, only one person is responding.
Yes, sir. So this is what the angle of friction is. I hope it is clear for all of you. So now coefficient of friction. Now the ratio of limiting friction to the normal reaction. Just now we discussed what is limiting friction. We all know what is normal reaction. So it is denoted by what? Mu. So this mu is what? This mu is what? Coefficient of friction. It is the angle between the limiting friction and the normal reaction. And it is denoted by tan phi.
Just now I said alpha, so you can also denote the angle of friction as phi. Okay, so this is basically the formula. It will be clear for you when you start solving the numericals. Okay, I hope it is clear for all of you. So, if you have any doubts, you can just ask me.